All right, guys. So we're not solving algebraically. We're going to reorganize this in a matrix. A matrix is not new math. It's just reorganizing of information. So what we're going to do is we're going to break up this system here. We're going to put all of the coefficients together in an arrangement. Then we're going to put all of the variables together in an arrangement. I'm going to recopy the equal sign and then keep the answers still over here on the right side. So remember, these are our coefficients. Y'all remember that's just a fancy word for the number in front of the letter. That's all that is. And then remember, our variables are here. And the answers are still over here on the right side. So answers are kind of pretty much in the same spot. All right, so for these coefficients, the first row right here, remember when there's not a number understood, what does it understood be? Yeah. So my first row in here is going to be 1, 2, 1. 1, and then a 2 is next to that y, and then a 1. The next row of coefficients, by the way, make sure it's always in the same order. All of my x's need to be first, all of my y's need to be second, all of my z's need to be last, which they are. So my next row is 2 for the letter x, 1 for the letter y, and -1 is next to that letter z. And then our last row is 1, 1, 3. And then when they are multiplied by the variables x, y, z, everything is organized, everything is in order. When I know what x, y, and z are, and when I multiply these two matrices together, I will get an output, I will get an answer of 8, 4, and 7. Okay, so this whole setup right here is called the matrix equation. And that is very important that you understand what that equation is. However, this really only helps me on a calculator when I know what x, y, and z are. We don't know what x, y, and z are. We have to solve for it. So I'm going to treat this matrix equation, the same process is the same. Don't write this down. Just watch me. It's the same process as that equation. What if I asked you to solve that equation, but you can divide? What would you multiply both sides by? 1/5, very good, which is the reciprocal, which from now on you guys need to understand it's the inverse. Of course, those would cancel out, and when I multiply the answer by the reciprocal, I get the letter. So, if you could please go to your calculator, go to the scratch pad, make sure it says scratch pad. Y'all type in 5. And we're going to raise 5 to the -1st power. Do y'all remember how to make an exponent?
Yeah.
It's way over on the edge. Remember the caret key? Raise it. So now we're in exponent mode. And raise it to the -1st power. Then hit enter. What do you get? The reciprocal. So instead of making my matrix right here, instead of making this a fraction, which would look crazy, a matrix with a fraction, I'm going to raise it to an exponent. That's what we're going to use in the calculator. So I will ask you, that is fair game for me to ask you, what is the matrix equation for this system? Remember, it's all the coefficients multiplied by the variables equals the answer. All of your letters have to be in the same exact order. Matrices are very organized. But there's something else called calculator ready, which is what we're going to use more often. And here's what calculator ready is. It's the coefficients raised to the -1st power, because that's the inverse. And we're going to multiply it by the answers. because that's going to tell us the X, Y, and Z. So I'm just going to recopy these coefficients in the same exact order. But remember, we're going to multiply by the answers, so I'm writing in an 847 right here. So this is what is called calculator ready. And y'all, when we type that in, it's going to give us the answers. Yes?
Where'd you get 847 from?
From the answers over here on the equal signs.
Oh.
Good question. Okay, so let's go ahead and hop over to the calculator screen. And guys, I might have to have your help because I can't remember all these numbers. All right, let's pull up the matrix template. To find the matrix template, it's next to number 9. So there's 9. Just hit the button right next to it. And there's a lot of different templates. We want the 3x3. Mine's already highlighted. Is yours already highlighted?
Yeah.
Okay, listen, I am going to go so slow like a sloth. Don't work ahead of me. Once you do it twice, you're not going to need me anymore. Just hang tight with me on this. All right, if yours is already selected, go ahead and hit enter. And then it's like, are you sure you want 3x3? Yes, we do. For this one, we do. So I'm going to hit OK. And then there's my template for my coefficients. So we're going to type those in. And guys, I use the tab key because I think it goes a little faster. So remember, the top row was 1, 2, 1. So 1, tab, 2, tab, 1, tab. And it automatically takes me to the next row. 2, 1, negative 1. And guys, make sure you use the negative sign. Don't use the subtract button. And then our last row is 1, 1, 3. 1, 1, 3. Okay. Is your cursor next to the 3? Is everybody's cursor next to the 3? All good? Okay. Use your arrow key to get out of the matrix. Your cursor should turn into a long cursor now. Y'all got a long cursor? Okay, now we're going to raise that to the negative first power, just like you did the 5. So raise it to your negative 1. Then arrow out of exponent mode. Make sure you arrow out because you need to go back to regular cursor mode, long cursor. And then now we're going to type in those answers, the 847. I need another matrix. So go back to the matrix template next to the number 9. You're still going to select the same one. We're just going to change the number of columns. We still want 3 rows. We only want 1 column. We only had 1 column of answers. So arrow down to where it says 1, then hit OK. And then type in those answers for those equations. 847. I did not hit a multiplication sign, but the Inspire knows to multiply these together. And you guys can leave the cursor next to the 7. You can just hit enter, and it'll give you the intersection. Did everybody get 131? And it goes in order. We had all of our x's first. The top number is x. We had all of our y's in the middle. The middle number is y. We had all of our z's at the end. The last number is a z. So that is what the variables equal, but that's not how we write it on our paper. So guys, remember, this is an x-plane, like an x-axis. This is a y-plane, and that's a z-plane. That's what gives you depth, back and forth depth. It's a 3D space. So this all intersects at 1, 3, 1. So you have to write your answer as an ordered triple. Was there a question? Yes. Okay, what's the question?
Did you tell us to make a y negative instead of a z negative? Because I'm like,
For every system, you have to make sure they're all in the same exact order. For numbers 1 and number 2, they're already in the same order. All of my x's are first, all of my y's are in the middle, all of my z's are at the end. So I am not writing the matrix equation every single time. I am going to write the calculator equation from here on out because that's what you need to be comfortable with. So remember, every single time it's always raised to the negative first power because we're kind of doing a shortcut. We're just going to go ahead and show the process to solve for the letter X and the letter Y. And the letter Z. So it's going to be 2, -1, -3 for your first row, 4, 3, and 2 for your middle row, and then -3, +2, and 5 for your last row. And we're going to multiply by the answers in order. So it's going to be a +1, a -4, and a -3. Now remember, that's going to give us X, Y, Z. But you have to write that as an order triple. Okay, so let me go ahead and type that in. Remember, your matrix template is next to the 9. And for the coefficients, we want it to be a 3 by 3. Y'all, what are those numbers that you wrote down?
2, -1, -3.
2 tab -1 tab -3 tab. Oh,
3, 2.
that makes
sorry, what was it?
4, 3, 2.
-3, 2, 5.
Don't forget, when you raise it to the negative first, you get out of exponent mode before you go to another matrix template. And remember, for your answers, you only want one column.
1, -4, -3.
1, -4. Okay. Did you guys get that?
Yes.
All right, cool. So just remember, if it is not a word problem, you just have to write it as an ordered triple. So 2, -6, and a 3. So this is why you're in Algebra 2. That stuff that we just did, anybody could do that. But you have to be able to write the equations. This is where the growth comes. I'm so sorry, guys. Okay, look. A company puts out different shaped signs. A package contains signs in shapes of squares, pentagons, and hexagons. There are 24 signs in the package with a total of 112 sides. If there are 10 more squares than pentagons, find the number of each type of sign in the package. Then you have this little table here. The first table where it says to define your variables, don't cut corners on that. It's going to frame everything else for you. Nathan, you with me? Check out your AirPod. All right, so we know there's a triangle in there. No, we don't. That's a different problem. We know there's a square, so I'm writing S for the square. I'm writing P for the pentagons, and I'm writing H for the hexagons. And I am going to write them in that order. All of my equations have to start with a letter P. With a letter S. A P is going to be in the middle, and the hexagons are always going to be the last piece of information. So, when you guys do this, if you follow this method, this is the best advice I have for you. Write the most basic equation you can write, then go back and fill in the detail, and then write what is ever left over. You have to be able to write 3 equations. If you can't write 3 equations, you can't solve for 3 unknowns. So if you can only write 2, you've got to go back and check your work. Okay, so when I say basic, I am talking about no coefficients other than 1. So like right here, guys, if I took all of my squares plus all of my pentagons plus all of my hexagons, how many would I have?
112.
112, that's the total shapes I would have. I would have 24 signs. 24 signs. I have some square signs, I have some pentagon signs, and I have some hexagon signs. If I put them in a big pile, there would be 24 signs in there. But that 112 is detail. It's about the number of sides. So what kind of detail do you know about a square?
4 sides.
Has 4 sides. Good. So this is going to be sides for a square plus sides for a pentagon plus sides for a hexagon equals total number of sides. If I'm talking about sides, I have to provide the detail about the sides for each unknown. All right, then we need to talk about what's left over. What is left over here?
2 more squares.
The leftover is there are 10 more squares than the pentagons. This part is the hardest. So remember, guys, if there are 10 more squares than pentagons, what do you have most of, squares or pentagons? So write an equal sign and put an S there, because we know we have the most of that. And then wherever it says more than or less than, it always goes at the end. So there's something plus 10. Something happened, then plus 10. That's going to give you the total squares. What goes in front of this plus 10? The P. Good job. P plus 10 is squares. Now, if you notice, what are my equations supposed to be starting with? S. But what is this starting with?
P.
You guys have got to rearrange it. It has to be in the same format. So this S, first of all, is on the wrong side. So we have to bring it over to the other side of the equal sign. So this is going to turn into negative S. I don't know how to use red. Negative S. And then the next letter that happens in my basic and detail is the letter P. P's already on the right side, so all I'm going to do is just copy it. And it's positive, so write plus P. Then what's next?
H.
H. Do we have any information about H?
No.
But you have to write it. So write plus 0H. All right, we're going to put our regular number over here, which is 10, but it's on the wrong side. It's a positive 10 over there, so what is it going to be over here?
Negative 10.
Negative 10. Okay. So where it says matrix equation, guys, I'm going to kind of change the instructions. Write the calculator ready. Matrix set up here. So remember, it's to the one with a negative first power, and we're going to multiply it by the answers. So my first row is all ones. My next row is 4, 5, 6. My last row, y'all, is negative 1, positive 1, and 0. And then what about the answers? What is the column going to be for the answers? Yes, it says 24, 112, and negative 10. And that's what you're going to type in the calculator. So while you are typing that in the calculator, guys, remember we are looking for the number of square signs, the number of pentagon signs, and the number of hexagon signs. Can I have a negative number of signs? No. Can I have like a decimal of a sign? No. So when you type this in, if you don't get positive whole numbers, you got to go back and check your work. Something's wrong. What did you guys get for that?
14, 4, and 6.
That is correct. Anybody else? Does anybody need help? There's 14 squares. There's 4 pentagons, and there's 6 hexagons. Any questions on that? You all have that on your screen. Y'all remember, if it's a word problem, you have to write it in words. So let's write, there's 14 squares at the bottom. 14 squares, 4 pentagons, and 6 hexagons. Wait, let's kind of check and make sure we're good here. Remember, you were supposed to have 10 more squares than pentagons, do you?
Yeah.
Yeah, you do. So we're on the right track on that. Very confident that's the correct